Hello, Integrated Math 2 students. Today we are going to begin our last unit of study. It's Module 4, Topic 2. We're going to be solving quadratic equations. So today's lesson, I have a lesson opener, pretty detailed. We're going to be talking about expressions versus equations. How can you turn an expression into an equation? And then we're going to be looking at quadratic functions, what we've already learned earlier this quarter, and then making that transition, that step to quadratic equations, what the relationship is there. Then the lesson will be in two parts with guided practice, and then that'll be it for today. And then tomorrow's lesson, you'll get the practice assignment. So let's begin. So we've been working with polynomials, which are good examples of algebraic expressions. Remember, we defined a polynomial, it was an expression. Are we able to find the value of x in the expression below? In other words, can we solve this expression, 6x minus 18? What do you think? We cannot solve expressions. We can evaluate the expression. For example, you could evaluate this expression when x equals 2. What's the value of the expression? What about when x equals negative 3? What's the value of this expression? Why don't you go ahead and find those for me? So when we evaluate this expression, 6x minus 18, when x equals 2, we simply substitute 2 in for x. When we simplify, we end up getting negative 6. When we evaluate it from when x is negative 3, we substitute the negative 3 for x, and we simplify that, and we end up getting negative 36. My question for you now is, what would be needed to change this algebraic expression into an algebraic equation? Can you provide me an example of how this could turn into an algebraic equation? I hope you remember we need an equal sign, right? So here's one possible example, 6x minus 18 equals 0. You could add 6x minus 18 equals 38, any number there. Example 2, we have it equal to another expression, right? So 6x minus 18 equals 2x plus 10. All right, now we have an equation. Let's have you solve 6x minus 18 equals 0. Okay, to solve this, we simply do the addition property of equality. We add 18 to both sides, so we get 6x equals 18. Then we do the division property of equality. We divide both sides by 6, and we get 1x equals 3. Can we check our answers? Yes, we can use substitution to substitute 3 in for x and go 6 times 3 is 18. 18 minus 18 equals 0. 0 equals 0. Check. We got it right. Now I want you to solve 6x minus 18 equals 2x plus 10. All right, I hope you got x equals 7 here. I did the addition property of equality, added 18 to both sides, and I did the subtraction property of equality, subtracted 2x from both sides. I showed that as one step. By all means, you could have did this 2 separate steps. So then we get 4x equals 28. Then I did the division property of equality, divide both sides by 4, and we get x equals 7. We do a quick mental check here. 6 times 7 is 42. 42 minus 18 is 24. And then 2 times 7 is 14. 14 plus 10 is 24. 24 equals 24. Check. Got it right. Here's a quadratic trinomial. This is a polynomial we've been working with recently. It's also just an algebraic expression, right? It's x squared minus 4x minus 8. Can you rewrite this expression as an equation? I hope you add an equal sign and you put a number or an expression on the right side of the equal sign to make your equation. So now we have x squared minus 4x minus 8 equals 0 in my example 1. And we also have x squared minus 4x minus 8 equals 3x plus 7 in my example number 2. Can we solve x squared minus 4x minus 8 equals 0? Why don't you give that a shot? Can you solve that? So I'm hoping you tried to solve this the way we've been solving those linear equations, and you did the addition property of equality, you added 4x to both sides, you added 8 to both sides. But then you get here, what would you do? So if you want to get rid of the x squared, how do you undo squaring? That's right, you take the square root. Here's the problem. We cannot take the square root of 4x plus 8. It has addition over here. We're not allowed to take the square root over this addition here because of the order of operations. So we're stuck. You could probably do a guess and check. You can go, if x is 1, would it work? You could probably play around. You might be able to get lucky and figure it out. but we don't have a way of solving it right now. And that's going to be the purpose of this unit right now, is we're going to learn a plethora of ways to solve quadratic equations. So earlier in this quarter, we were studying quadratic functions. And there's three forms that we studied right before spring break and right after spring break. Do you recall the three forms of quadratic functions? So the three forms are standard form, where we have f of x equals ax squared plus bx plus c. We have factor form, f of x equals a times x minus p times x minus q. And vertex form, where you have f of x equals a times x minus h squared plus k. And that's in function notation. We also put it in equation notation. We're using y. Y equals those. All right? I want you to understand right now, this equation notation is not the quadratic equation form we're going to be using. We're going to be using quadratic equations where we do not have a y. We only have an x variable. So that leads me to my question for you. How can we change these functions into quadratic equations with just x as the variable? So you can have x squared, you can have x to the first degree, but no y or no f of x. How can we make that change? I'm hoping you just replace the f of x or the y for each one of those with a number. And I just use the real easy number, 0. So I just put an equal sign in there to 0 for all of these. So now we have standard form for a quadratic equation. We have factor form of a quadratic equation. And we have vertex form of a quadratic equation, just like we did with the function notation when we studied those three forms of quadratic functions. Exactly the same. So take out your gold notes. Here's going to be our first method, solving quadratic equations using the square root method. And we're going to start with standard form equation, ax squared plus bx plus c equals 0. And we're going to do this when b equals 0. So first thing I want to make note is down below here. You see the red? We can only use this method to solve when we have a b value that is 0. So if b is other than 0, we're not going to be able to use this. So example 1 here in the red is, if we had 3x squared plus 4x plus 12 equals 60, we're not going to be able to solve using this method. If we had x squared minus x plus 8 equals 0, we're not going to be able to solve using this method, because the b value in the first example, b is 4. The b value in the second example here is -1. So this method is only going to work in special situation, like our example here. 3x squared plus 12 equals 60. All right. So our first step is going to be, we want to go ahead and get the number on one side, the x squared on one side of the equal sign. So I'm going to subtract 12 from both sides. Subtract 12, subtract 12. So now we have 3x squared equals 48. All right, tell me, what are we going to do next? That's right, we're going to do the division property of equality, right? So we can divide both sides by 3. So when we do that, we get x squared equals 16. But we're not done. It says solve for x. This is x squared. So now how are we going to get just x? To undo x squared, we take the square root. So by what you do to one side, you must do to the other. So we take the square root of both sides. Now, when we take the square root of both sides, there's two roots. There's a positive and a negative root, right? Because the square root of 16 could be, well, 4 times 4 is 16, right? So it could be 4. And then is it -4 times -4 also positive 16? That's right. So we get x squared equals plus or minus square root of 16. And since that's the perfect square, it comes out nice and pretty. So x equals plus minus 4. So I want you to make sure you understand what this plus minus symbol means. We have two solutions, right? X equals -4 and x equals positive 4. Oh, can we check these? Sure you can. You substitute it back into the original equation and see if it works or not, right? So you substitute 4 for x. Remember your order of operations. 4 squared, 16. 16 times 3, 48. 48 plus 12, 60. 60 equals 60? Check. All right, try -4. -4 squared, oh, that's also positive 16. 16 times 3 is 48. 48 plus 12 is 60. There you go. We solved our first quadratic equation using the square root method. And again, this only works when we don't have x to the first degree. If we had x to the first degree anywhere in our equation here, this method would not work. So for your notes, step 1 is you're going to isolate the x squared on one side of the equation. So we want to isolate 1x squared is what we did. So we have that on one side and the number on the other side. And then step 2 is you take the square root of both sides and simplify. So you might want to add those steps to your notes. Let's try some. First one, x squared equals 25. Real basic here. Solve this one for me. All right, I hope you got x equals positive 5 and x equals negative 5. You take the square root of both sides right away. And so x equals plus or minus the square root of 25 happens to be a perfect square. So it comes out nice and pretty. X equals positive 5, x equals negative 5. Let's try another one. 4x squared minus 10 equals 54. So this one's not good to go yet. You're going to have to manipulate the equation a little bit first. So you got to do that first step. Let's isolate 1x squared first, and then you can take the square root of both sides. So on this one, the first thing I did was I did addition property of equality. We added 10 to both sides. So now we have 4x squared equals 64. So then I did the division property of equality, and I divided both sides by 4, and we got x squared equals 16. And then I took the square root of both sides, so we get x equals plus or minus the square root of 16, which is x equals plus or minus 4. Just going to show you another way you could have solved this as well. It wasn't the way I set it up for you in the notes, but by all means you could have done this since you had a perfect square on the left and right side of the equal sign, right? 4x squared is a perfect square. You take the square root of 4x squared, you get 2x. And 64 is a perfect square. Take the square root of 64, you get 8. So we could have actually did the square root method right there. Take the square root of both sides, and we would have had 2x equals plus or minus 8. And then you would have divided both sides by 2, and you would have got x equals plus or minus 4. So just another way you could have solved this problem. Solve x squared plus 28 equals 100. So in this one, we would subtract 28 from both sides, the subtraction property of equality, and we get x squared equals 72. We take the square root of both sides, and so we end up getting x equals plus or minus the square root of 72. But this time, we don't have a nice, pretty, perfect square. So what we're going to be able to do in this class is we just use our calculator and take the square root of 72. And this might look like a funky equal sign. I did little squigglies like this. That's just showing you that x is approximately 3.49. That's if I need to round to the nearest hundredth. If I need to round to the nearest tenth, you could just say approximately 3.5. And I forgot something almost there. What I need to make sure I have. That's right. I need the plus minus symbol, right? Because it's positive 3.49 and it's negative 3.49. That's very important. So don't forget, like I almost did, the plus minus symbol there for the final answer. Now, I will say, you may see if you start doing any research or you look at other videos, there's a method for simplifying radicals. We are making a choice right now with the distance learning program to not go into that detail, how to simplify the radicals to get your answer as a simplified root. So if you ever see any of that, any practice problems I give you and I accidentally forget to take that out, it says leave as a simplified root, you can ignore that and just give me the decimal answer for now. All right, one more. We have 10x squared plus 30 equals 20. See if you can solve this one. Did you notice this one's a little funky here? You subtracted, I should say, 30 from both sides, subtraction property of equality. So then you got 10x squared equals negative 10. You divided both sides by 10, you get x squared equals negative 1. So then you may have tried to take the square root of both sides, and you end up getting x equals plus or minus the square root of negative 1. But is that a real number? Can you have a square root of a negative number? What times itself gets you a negative 1? Wasn't that impossible? because once you need a positive number times a negative number to get -1. So the smallest absolute, is not absolute value, the smallest square root number we can have is 0. We cannot have a negative integer or a negative number inside the radical because it's not going to give us a solution. So in this example right now, it's going to be x equals no solution. All right. And I will just say this as a disclaimer. Down the road in your math career, probably pre-calculus, you're going to learn something about imaginary numbers. And so when you learn about imaginary numbers, that's going to be a solution for a negative square root. So down the road, just sneak preview, you don't need to know this for now, but you'll get, this will actually come out to be plus or minus I. It'll be imaginary solution. But for now, you don't need to worry about this. Whenever you get down, you've isolated x squared equal to a negative number. When you get there, we know there's going to be x equals no solution. There's no real solution to this equation. All right, back to your gold notes. Let's look at solving quadratic equations using the square root method again. But this time, we're going to be given vertex form of the equation. So a times x minus h squared plus k equals 0. So here's our example. We have 4 times x minus 6 squared plus 5 equals 41. First step, subtract 5 from both sides. So subtraction property of equality, and now we have 4 times x minus 6 squared equals 36. So our next step, I want you to take note here. We do not distribute the 4 with the parentheses there, because it's x minus 6 squared. Order of operations, you have to do exponents first before you do multiplication. So you'd actually have to go x minus 6 times x minus 6, and then multiply by 4, and boy, we'd have a mess. What a mess. So we're not going to do that. Instead, we're going to undo the multiplication here by using division. So we divide both sides by 4. So now we have x minus 6 squared equals 9. Please note the x minus 6 is in parentheses squared. Okay, so that's different from before when we saw like maybe just x minus 6 without parentheses just to the first degree. So since we have x minus 6 squared, we are now going to be able to take the square root of both sides. So after we take the square root of both sides using the square root method, we are going to get x minus 6 equals plus or minus 3. So remember when we did absolute value equations and how we broke the equation into 2 equations? That's basically what this is. This is x minus 6 could equal 3, and x minus 6 equals -3. So my next step is I'm just going to solve those 2 little equations to get my answer. So x minus 6 equals 3. We add 6 to both sides. X equals 9. Then x minus 6 equals -3. We add 6 to both sides, and we get x equals 3. Can we check them? Absolutely. I'm not going to write it out, but let's just do it mentally here. So substitute the 9 in for x. 9 minus 6, 3. 3 squared, 9. 9 times 4, 36. 36 plus 5, 41. 41 equals 41? Check. Let's substitute the 3 in for x. 3 minus 6, -3. -3 squared, +9. 9 times 4, 36. 36 plus 5, 41. 41 equals 41? Check. So steps for your notes. Step 1 is we isolate the parentheses. All right, so if we have a number, we have a k value, we're going to add or subtract that from both sides, whatever the opposite of that value is, to get that to become 0 on the left side. And then we'll do the division here with the number. Please make sure you move the number first, that's by itself, using addition or subtraction, before you do the division property of equality. Or if it was 1/2, it'd be the multiplication property of equality, right? So before you do that, make sure you move basically the k value here first. And then you can multiply or divide both sides by something to get rid of the a value, make it 1. Shouldn't say get rid of it, make it 1. So isolate the parentheses. That's the first step. So very similar to what we did with standard form. And then the next step is just like we did in standard form, where you then take the square root of both sides. And then we have to solve for x. So the only difference here is when we had standard form, we usually had down to 1x squared. So once we took the square root of both sides, we had the answer. Here, we're going to have some type of binomial, typically, that we're going to have to then solve for x. So we have to write the two equations. A little bit harder, that's it. Let's practice. X minus 7 squared equals 121. It's already isolated for you. Good to go. So you take the square root of both sides, and you get x minus 7 equals plus or minus the square root of 121, which is a perfect square, so that becomes plus or minus 11. Then we're going to go ahead and say x minus 7 could equal negative 11, or x minus 7 could equal positive 11. So we solve this by adding 7 to both sides. We get x equals negative 4. And on this one on the right, we get x equals 18. Let's do a quick check. If I substitute negative 4 into the original problem, I'll get negative 11 squared. And I square negative 11, I get 121. Check. If I substitute 18 in for x, 18 minus 7 is 11. 11 squared is 121. Check. All right, next level of difficulty. 6 times x minus 3 squared plus 11 equals 53. So my hint for you is I want you to get rid of the 11 first and then work on getting rid of the 6. See if you can solve this one. So this one's a little bit of a beast here, right? So we subtract 11 from both sides and we get 6 times x minus 3 squared equals 42. Then we did division property of equality, divide both sides by 6, and we get x minus 3 squared equals 7. So now I took the square root of both sides, right? So when we do that, I take the positive and negative root, but golly gee whiz, 7's not a pretty number. It's not going to be a perfect square, right? So we get x minus 3 equals plus or minus the square root of 7. So then I took the square root of 7 on my calculator. I got about 2.65. I rounded a little bit to the nearest hundredth. So we have x minus 3 equals plus or minus 2.65. Break that into two equations, equal to negative 2.65 and positive 2.65. We add 3 to both sides. So we get x is about 0.35 and x is about 5.65. This one's going to be a little bit harder to check. We can do it with the calculator. We could check it. But since we rounded here, it's not going to come out to be exactly 53 equals 53. It'll be a little bit off because of rounding error. But you'll know you'll be pretty darn close if you want to check it that way. You can. Okay, solve x minus 3 squared plus 21 equals 12. All right, threw you a curveball here. So most of you subtracted 21 from both sides. So then we had x minus 3 squared equals negative 9. So then you probably went to take the square root of both sides. So you get x minus 3 equals plus or minus the square root of negative 9. So I'm hoping you saw that and you went, wait a minute, we can't have a square root of a negative number. So for now, that is no solution. Now, I bet you some of you thought you took the square root of that and probably put plus or minus 3 somehow. You thought you could take the, or maybe you said plus or minus negative 3. I don't know. You can't do that. Okay, so if you did that, you made a mistake. You weren't able to solve for x in this problem. We get no solution. All right, one more. All right, this time we have 9 times quantity x minus 3 squared minus 23 equals negative 5. Oh, it equals negative 5. Does that mean it's going to be no solution? Wait, not so fast. Remember, you have to isolate the binomial square by itself first before you take the square root. So let's see what happens on this problem. So we add 23 to both sides. So then we get 9 times x minus 3 squared equals positive 18. Then we did division property of equality, divided both sides by 9. So we get x minus 3 squared equals 2. Aha! It's a positive number when we've isolated the binomial square. So there is going to be a solution here. So then we take the square root of both sides. So we get x minus 3 equals plus or minus the square root of 2. So on your calculator, it's about 1.4. You might have said 1.41. I just rounded the nearest tenth this time. So x minus 3 is approximately equal to plus or minus 1.4. So then I'm writing my two equations. X minus 3 equals negative 1.4. X minus 3 equals positive 1.4. So I add 3 to both sides. I solve those. I get x equals 1.6. and x is equal to 4.4. And yes, those are approximate. I could do a little squiggly equal sign if I wanted to on that one. But about 1.6 and about 4.4. Another way you could have done this is you could actually keep the square root and then just add the 3 to both sides. So then it would look like this. First equation would be x equals 3 minus the square root of 2. You just keep those separate because they're not like terms, right? And then that one would be 3 plus the square root of 2. If I write the 2 there we go. 3 plus square root of 2. So that would be this equivalent. This would be the exact value. 3 minus square root of 2. 3 plus square root of 2 would be precise, exact value versus the 1.6 and the 4.4 approximate solutions. Last section for your gold notes. You're going to like this. This is going to be quick. Solving quadratic equations using square root method for factored form. So that's when we have a times x minus p times x minus q equals 0. So example, 3 times x minus 6 times x plus 8 equals 0. We're not allowed to take the square root over all these different factors here being multiplied with each other. We cannot take the square root over all that. So we're not going to be able to use the square root method. So you may just put down your notes that we will not be using the square root method for factored form of an equation. So it will not be used. Boom, we are done for the day. So I've been asking you guys to take notes. Obviously, I don't have a way to check up on your notes, or I'm not going to be that detailed where I'm going to ask you to take pictures of your notes and send them to me. But I noticed that some of you are not following that process, because when I'm going to give you the practice problems tomorrow, I want you to be able to refer back to your notes and go through those and do those problems. Okay, I notice a lot of you are not referring back to your notes, so I'm not sure if you're not taking down the notes. Okay, if you're taking shortcuts, at minimum, you should be taking my slides and Google Slides, and you should save those as your own copy of the notes that you're accessing. So you could take all my Google Slides I'm giving you in Google Classroom and make those your own. By all means, you could also add additional examples to those if that works for you. So that is a possibility. So ideally, you are taking down the notes and using them. It just helps with the learning process. But that's it for today. I think we had a good day today, I hope. Let me know how it worked out for you, and then look for tomorrow's assignment. We'll be practicing this. Have a great day, evening, or night.